divided TD 1 minus Z inverse 1 plus Z inverse minus S5. Seriously, that's what we do, okay? I don't know if we have a simpler expression for this. Do we? Do we have a simpler expression for this? But in general, okay, or another way, let's explore a different possibility. Omega C to the 5th power divided by, so in general, this thing having 5 roots, we should be able to figure out, actually I don't know how to figure it out, yeah. So it's S plus S3, no, S minus 3, S3 is real, okay? So we can put it in conjugate pairs, yeah. Because S1 and 5 are conjugate pairs, and 2 and 4 are conjugate pairs, right? So 共二复数嘛，共二复数. So if you know the property, we can put in, it's actually S, I know is minus 2 omega C cosine of 108 degree S square plus omega C square. Yeah. So that's one term. And another term is S square minus 2 omega C cosine. So 2 and 4. Okay, 2 and 4 is 144 degrees. 144度, 144 degrees. Yeah. S. So let's remember that's a constant. This is also a constant S plus omega C square. So, 5th order polynomial having 1 real root and 2 pairs of complex conjugates. There are different ways to organize to factorize the polynomial. But still, whenever we see S, right, make it 2 divided by TD, 1 minus Z inverse, 1 plus Z inverse. Pretty tedious, yeah. Whenever we see S, we need to replace it with here being S, 2 divided by TD, 1 minus Z inverse, 1 plus Z inverse, everything square, yeah. And whenever we see S, replace it by Z, by that. So you see that this becomes very tedious. Yeah. It turns out that this is really, really tedious. Okay. S squared and so on and so forth. Whenever we see S, make sure that we replace S by S of Z. So first step may be pretty tedious. Okay. But then why do I need to emphasize this? Because in the end, I claim to you this is a design, but in what sense? I claim to you this is a design, but in what sense? In the end, we need to, let me say this, I'll repeat it, listen to me. In the end, we need to somehow organize this expression so that it becomes equivalent to a difference equation. So in the end, we need to organize this into blah, 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 into B of Z divided by A of Z. Then, where each of them is a polynomial of Z inverse. When we reach this outcome, we reach this step, then we know how to convert it into a difference equation with what? Linear constant coefficient. Okay, then we can turn it into a linear constant coefficient difference equation. That's the final goal. Okay? That's the final goal. And this is just showing one intermediate step. Okay? The final goal is to organize our expression so that G of Z with this definition equals to BZ divided by AZ. Do we have it yet? Not yet, okay? Not yet, because the bottom part, the top part, yeah, is a constant, but the bottom part is too nasty, 太脏了, 对不对? It's too dirty, okay, too complicated. So we need to somehow change the format into this format. That's our goal. Is that clear? Our goal is to change GFZ into this format. So I give you a clue, okay? How about let's take a look at what's happening down here, okay? What's happening down here, maybe this expression is easier, okay? It's pretty easy that now we can multiply each of them with, this is not supposed to be here. That's the problem, where the problem is. We need to move this term, 1 plus z inverse. We need to move it to the top. No? We need to move this to the top, okay? So how about we just do some multiplication. We multiply the top and the bottom by many times of 1 plus z inverse. Okay? So this is going to move to the top with 1 plus z inverse. And then don't forget there now is a 1 plus z inverse next to S1, where S1 is a complex constant. And we're going to similarly just multiply the denominator by another factor of z 1 plus z inverse. But now we have 2 powers. 1, 2, eventually 1, 2, 3, 4, 5. There's going to be a 5th power. You know what I mean? 1, 2, 3, 4, 5. Okay? 3rd time, 5th time, 4th time, 5th time. Okay? Okay, so maybe that's my suggestion. It's probably easier this way. So let's forget about this. Let's forget about this. So what do we have? So now finally on top we still have omega c to the 5th power. At the bottom we have 1 plus z inverse is going to show up 5 times. Okay? And at the bottom we have, what do we have? We have a 2 divided by TD. Now 1 minus z inverse minus S1 times 1 plus z inverse. So that's one term. And there are 5 of them. Okay? There are 5 of them. Second one, third one, 5th one, and 4th one. And the 5th one is 2 divided by TD. 1 minus z inverse minus S5, 1 plus z inverse. Okay? So that's what we have. Okay? That's what we have. So almost there. So now do we have a polynomial on top? Do we have a polynomial at the bottom? Yes. The answer is yes. Now this is a polynomial. This is going to be a polynomial of z inverse, and on top we also have a polynomial of z inverse. Okay? So that's kind of the tedious calculation we have to go through in order to get this final outcome. We want to organize the expression of gz, which looks quite complicated at the beginning, but yeah, yes, we can just be patient and change it into this format. And change it into this format. So what do we have? What do we have here? It's still pretty complicated. Yeah. Okay, so good news is that I'm not going to ask you to go through this to find exactly what is A of z and what is B of z. But it suffices to say that in A of z, it's going to be a 5th order polynomial. And B of z, what is B of z? B of z is easier. Okay? B of z looks like that. Okay? So there are a few observations. So S of z, no. We have a few notes that we can make. The first note is that A of z has a multiple root. A of z has a 重根啊，一个 multiple root, a fifth order multiple root at z equals to -1. Okay? A of z has a fifth order multiple root at z equals to -1. Okay, so that's one observation, yes? Has a fifth order multiple root at z equals to -1. Okay? Oh, that's not A of z, B of z, I'm sorry. Yeah, B of z, top. And how about A of z? A of z should have also have 5 roots, yeah, because it's also a fifth order polynomial of z inverse. But where are they? Okay, but where are they? Okay. So now we need to take a closer look at that. Okay, let's take a closer look at this. Okay, because each of these brackets will contribute to one pole. Okay, this bracket contributes to one pole. So let me show you. If we just expand, okay, do the expansion. So now what do we have? In here we have, it seems like we have S1, no, what's the constant? The constant part is 2 over TD minus S1. And then on the right, what do we have? We have minus 2 over TD plus S1 Z inverse. Okay, we have this expression. We have this expression. So having this expression contributes one pole. Okay? And what is it? So I'm asking what z. So then we find one pole at z equals to what? S1 plus 2 divided by TD no. Oh, this is dirty. Not here. No. So I want to show you how to make this expression become 0. Okay. That's one root of this polynomial, which is a pole of g of z. Okay. That's what I mean. This bracket contributes one pole to g of z. Okay. So let's try to figure out at what z will we get a 0 right here. We get S 这个要过去再过来啊 seems like it should be 2 divided by TD minus S1 and 2 divided by TD plus S1. Yeah, I think that's the answer. Okay? Or, yeah, so that's the answer. Okay? So now, this is my second note. Okay? We know each bracket contributes one root to A of z. So we have 5 of them. So then, this is a root of A of Z. Okay? So how about Z, J, S, J, S, J, where J can be 1, 2, 3, or 5, all the way to 5. J equals to 1, 2, 3, 4, or 5. Okay? So that's our observation. Finally. Hey, is that making sense? Everything making sense so far? Just remember that the final goal, theoretically, okay? Theoretically, we need to organize G of Z. It has a complicated expression at first, but by just carefully observing the expression, we note that, first of all, it has a multiple root, a fifth order multiple root on top, okay? That's one observation. The second observation is that each of these brackets contribute one pole to G of Z, and they are located at Zj, where J equals to 1, 2, 3, 4, 5, okay? And we'll get back to this. Okay, we'll get back to this. All right, so that's, the technical question we were asking, okay? Let's take a look again. I've claimed to you that this is a design. And that means we can systematically derive a rational. This G of Z can be expressed in terms of a rational function, which means the ratio of two polynomials. So that is to say, okay? So may I elaborate this further? Okay, before we enter the next topic, so let me elaborate this further. Okay, so now each bracket contributes to one pole. Okay, so in general, the entire A of Z can be expressed as the product of 1 plus Z, 1 minus ZJ inverse. That's what I'm trying to emphasize. ZJ, okay, yeah, J, yeah. Times a constant, okay? Times a big constant, okay? There's still a big constant right here, and the constant seems to be there's still a big constant right here. You see that actually each bracket has this constant that needs to be put to the outside. Okay? That has to be put to the outside. So let me just write it. So now this big constant, what is it? The big constant is product of J from Y to 5, 2 divided by TD minus Sj. Okay, so that's a big constant right here. Okay, that's a big constant right here. That should have been put actually to the top, to the top. Yeah. But yeah. Okay. So if we call this big constant big C, yeah, this is just big C. So in the end, how do we have? We have BZ now is this omega C fifth power divided by big C times 1 plus Z inverse to the fifth power. That's B of Z, the final form of B of Z. Whereas A of Z now becomes this is A of Z is this. This is A of Z. That's A of Z, and B of Z becomes omega C, the original B of Z, and divided by this constant. Okay. And then finally, we can talk about implementation. This is probably the point I really want to deliver. Okay. Now, spending so much effort on the board, A of z is a polynomial with leading coefficient 1. So A of z now becomes a polynomial with leading coefficient 1. 1 plus A1 z inverse plus A2 z to the minus second power all the way to A5 z to the minus fifth power. Okay? You can figure it out, A1, A2 all the way to A5. Whereas B is also a polynomial of fifth order. So it's actually easier. It's omega c to the fifth power divided by this big constant and what? 1, 1, 5, 10, 15, 1嘛, Okay, 1 plus 5z inverse plus 10z minus second power, 10z minus third power, 5z minus fourth power plus 1 times z fifth power. Okay, so that's finally B of z and A of z. Yeah, we are announcing A of z and B of z finally. Okay, and only at this point now we are ready to talk about difference equation. Okay, because now we have B of z and A of z, we know how to write down the corresponding difference equation. So we are going to change it into this form. We're going to change it into, therefore, y of n equals to minus a1, y of n minus 1, and so on, a2, y of n minus 2, and so on, blah, 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 plus b0 times b1 z inverse, blah, 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 plus fifth order b5 z to the minus fifth power with all the coefficients being constants. Okay? Long process if you were to do it by hand. Okay? If we do this by hand, fifth power, that fifth order filter, that's how much of calculation it takes to finally convert this design. This is a design into a difference equation. That's the amount of effort we need to put in to get to a difference equation. Then this is one line of code. Then it becomes one line of code which you can implement. Yeah. Okay, so a lot of details right here, but we know this can be automated. I mean, yeah. This is a design process that has been fully automated now. Let me mention that this is going to be a homework, okay? In the next homework, now I wish to show it. Yeah, okay. So let's take a 2-minute break. So I'm going to ask the TA to set up the projection so we can take a look at the homework. So in the homework, I want to show you that now this is A of z and B of z is just one line of MATLAB, which does this for us. And we're going to use MATLAB for running our filter. Okay? 那切换一下好了啊，你有 download 作业吗？你的电脑有 MATLAB 吗？没有，你要看一下，我可以再试一次吗？啊，怎么会这么奇怪？ Yeah. OK， 好，那就 thank you for let's thank the TA. Right. So in this homework, we are going to have both the handwritten part and the computer part. Okay. The handwriting part, the first one will involve you need to use the bilinear transformation. The second one is about third order Butterworth filter. Okay, and the third order Butterworth filter turns out that the three roots are at like multiples of 60 degrees, 60度的整数倍啊. So it's easier. Turns out that it's a transfer function you can easily write down. It's just expand the bottom part into a third order polynomial right here, and then I will just want you to repeat, show me that this expression, that expression A, you can apply it for the third order case, and you get this function of S. And then now by applying the bilinear transformation, I want to ask you if that omega corner frequency of the prototype is at 2000 radian per second, and what's this important parameter TD right here? Okay, this takes some calculation TD, such that the corner frequency is exactly at pi/3. Okay, now, and that's a handwritten part, and the second part is the computer part. Yeah, now I want to show you the computer part. It's really small. Okay. So here, I created an audio file. Okay. This audio file is my pronunciation of two English letters. It's S and F. Okay. So I pronounced a series of S and F. 你有 download 这个档案吗？有的。好。那 let's run it. All right, so as you can see in this code, we are going to set, in MATLAB it's very convenient, we can set the corner frequency in your design in G of Z, okay? Set the corner frequency at pi/3, and then just this part of the code, we read the file, reading this audio file, audio read, and you can also check the audio info, sampling rate and stuff like that, okay? And then one line. This is how to design Butterworth filter using MATLAB, okay? We were going to run it using the entire board. In MATLAB, it's just easy. Specify your order. In this case, it's 3. Okay, specify the order, use butter. One function, butter, order your corner frequency, and give you B of Z and A of Z. It's that simple, okay? So don't worry if this takes up too much time. Now everything is just one line of MATLAB. Okay, this is what I want to ensure you. And from there, you can plot, use a freq Z to plot the frequency response, the magnitude response in dB, as well as the phase response. Okay, you can put, that's a very useful function to know of, to freq Z. And then we can process any input with the filter. Knowing B and A, okay? Knowing B and A, we can just filter our signal with BZ divided by A of Z. So that's simple. No more than 25 lines of MATLAB, okay? Already we can plot frequency response. We can filter the signal. So now I want you to listen to, 刚刚没有出声音了. Yeah. 好. So let me, maybe instead of listening, let's make a plot. So this is our speech signal. Okay, that's a speech signal. Yeah. And then after low-pass filter, the result is Y. Doesn't change that much. Okay, it does not change that much. But I can try to lower the cutoff frequency right here. So we can try to lower the cutoff frequency. Let's say it's pi over 3. Let's reduce it to pi over 12. Okay, and also let's increase the Butterworth filter. Okay, let's increase the order to, let's say, 10th order. Okay, so we expect to see what? We expect to see a more sharp transition for the low pass effect. And yeah, let's run it. You see, okay? So now the magnitude response is going to drop faster. Okay? It's going to drop faster. Phase response will also change a lot. And unfortunately, we're not listening to the sound. Can we? Yeah. I want to, so now seriously, we are talking about filtering my professor's pronunciation of F and S with a corner frequency around 0.1 times Nyquist, okay?
S.
Yeah, 所以这是可以的。它 MATLAB 可能得重开才行。先放这个啊。Yeah. So let's listen to, bear with me, listen to my, yeah.
F, S, S, F, S, 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 F, S.
All right, so can you tell me this, what is, can you transcribe my 做听写可以吗？要不再听一次啊。Transcribe, yeah, Professor.
F, F, S, S, F, S, 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 F, S.
See, so remember that near the beginning of this semester, I really want to deliver this to you. This is a nice homework, newly designed. I was mentioning there was a problem, your traditional telephone line sampling at only 8 kilohertz with a Nyquist rate of 4 kilohertz. So a lot of speech information, actually the high frequency part is missing already. So I was trying to suggest to you, try this at home. S versus F when low pass. Finally, we get a chance. Now we have a low pass, it's a Butterworth filter of any order, okay? Apply that on my pronunciation or your own pronunciation. Try this at home. Record the sequence of S and F and low pass. Okay, so now do we have the result of low pass? Yes, okay.
S, F, F, S, S, F, S, 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 F, S.
So welcome to the world of low pass, okay? Now we have hearing problems. So in this homework, I want you to try, tell me what? I'm going to ask you to turn in a short report, page limited to 2 pages, and we are going to design a filter, try a few things, changing the corner frequency and change the order N so that using A of Z and B of Z, we can low pass our signal. And finally, now in the last part right here, I suggest using a 16th order Butterworth low pass filter to process this file. And I'm curious, okay, I'm curious, what's your opinion? Do you think S and F are still clear even though they're a timbre, the insert timbre, okay? Even though the timbre might sound different. 刚刚有没有 different? Is it different? Is it different? It's So it's bad. Yeah. So then I want you to investigate. Please do this investigation for me. How much do you need to lower the cutoff frequency? I was setting a really low cutoff frequency. If we push it back to something better, you can change the corner frequency. I'm curious, what's your opinion? How much do you need to lower the color frequency so that you cannot clearly hear the difference anymore? Okay, how low is too low? Okay, how low is too low? So right now I was setting it at a pretty low color frequency. Okay, but when we just increase it, can you hear the result clearer and clearer? Okay, so that's a kind of an exercise I created for you. And there's a final remark. Actually, this is my answer. Okay, the file name is the answer. Okay, thank you for being here. The file name SSFS. SFSSFS. That's the answer. Okay, check the answer. So now, knowing the answer, it might become unfair. When you already know the answer, you cannot answer this question of how low is too low, because you already know the correct answer. Okay, so maybe I beg you. Okay, so if you're really interested, ask your roommate. After low-pass filtering, ask your roommate, or your friend, or your family, or any random person on the street. Can you tell me, is it S or F? Okay, at a random order. Okay, this is some suggestion for you for this exercise, but otherwise, we are almost running out of time. Sorry for the technical difficulties. We'll figure it out. Tomorrow will be the discussion for the handwriting part. Okay? Tomorrow, let's still just hold the discussion session for the handwriting part. It's going to be a total of 2 questions, so we may have, how many? 3 volunteers for each. 只剩2个题是吧？剩2大题，对啊，2大题各挑3个人好了。好 yeah, so that's the way we are going to do tomorrow's discussion session. All right, so yeah, 只剩5分钟，我先下课啊，好，谢谢啊。